Yes, sir. Hello.
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 No,
Hello.
you're ready, sir? No need for webcam.
Webcam is not needed. Huh?
No, sir.
Okay, I will just close the webcam. Okay. 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 Hello.
Yes, sir.
Uh, so just I'm ready with the PPT. Just when you ask me to start, I will just start it.
You're already live, sir. Please go ahead.
Okay. Okay. Thanks. So I will start the presentation.
Yes.
Okay. 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 Good afternoon, everyone. Uh, Before starting, I will just like to remember the words of late President Dr. APJ Abdul Kalam. Educationists should build the capacities of the spirit of inquiry, creativity, entrepreneurial, and moral leadership among the students and become their role model. So, with this sense of responsibility, I will just like to start our work presentation. Myself, Srishal ML, faculty in Mechanical Engineering Department, have co-authored with Professor CM Kuti for the work of augmenting the art of classroom learning of machine drawing laboratory course. So regarding the highlight of our work, I just like to focus on the language of the engineers, where we want to enhance and elevate the graphical communication skills. And given the opportunity, students will never go out of this kind of activity where they can learn something in the art of. From this, we have attempted for two more practices, which is uh, worth sharing. So here is the actually work carried out from from our paper. And so when we just did the literature survey, we what the important thing was regarding not just a technical professional colleges, but the secondary school level in the Malaysia, they have included the technical engineering drawing in the curriculum since the past 2 decades. And this indicates the earlier exposure to the students regarding the technical knowledge and creating awareness and also preparing them to learn to read the drawings. So when they learn to read the drawings before they learn to read the drawings, the best way is to learn to prepare them. So in our curriculum through our machine drawing laboratory course, we wanted to improve the skills and also minimize the gap whatever is there in the skill level. So this small activity has been a kind of experiment or kind of activity over here. So we just started the three specific program outcome elements. They are the indicators, namely to demonstrate the ability to do the measurements. And second one to generate a detailed drawing. And the third one is the ability to create computer models and technical drawings. So after teaching the student, after teaching the basis of machine drawing to the students, this activity was being started out, and this was named as key lock activity. So this activity is actually addressing the activity which is very simple and creativity in itself. And this activity we want to do it be appropriate, inclined to our machine drawing course content, and it should be pedagogically sound and that means you should make student feel comfortable to make sense among the student learning point of view only. And we started this activity once they completed almost 80% of their machine drawing basic course. So the starting of this activity was like formation of the students in a team of 5 students with a team leader, where the team leader had that sense of responsibility in guiding the team members. So the outcome of this innovative activity, pedagogical activity, has been satisfying in getting the targeted above 3 targeted indicators. So getting in depth into this activity details, five teams, uh, 5 teams were there. Each team considered 5 students, including one team leader. So before getting into this activity, the student has to pass to some things in assessment kind of things. He has to complete all basic course contents, and since the class had a diploma into students also, they had to have the basic engineering drawing knowledge. And then the second thing was here any student can approach the faculty one team at a time only. That means in the normal classroom where 80 students will be there and one faculty will be addressing all the 80 students on an average. But this doesn't should not happen in the out of classroom activity. That was our main intention. So one team means 5 students at a time, guided by one faculty. And most important was only in the free time when the students were free to learn, apart from the scheduled timetable or also the scheduled class hours. Only in their free time they have to approach me. It's not like they have to approach inside the classroom or inside the department, where anywhere in the campus. If they have any doubt regarding these things, they can they had that flexibility to approach me. And this made them feel more responsible also when they were in 5 students team when compared to the 75 student or 80 plus class. The students were also asked to carry out this activity in either machine shop or else metrology laboratory. But students worked in these 2 laboratories, but most students outside this laboratory they were working because of getting those restrictions bypassed. So instructions were clearly given to all the team members, the students, and especially the team leader was taking care of the deadlines regarding the this activity. And each team was given one key, one lock, 2 calipers, and drawing instruments. And they were undergoing with a detailed explanation of how to prepare the technical drawings, so that any engineer in this or on this globe can easily read it without any issue. So a rough sketch, initially the rough sketch was prepared of both the key profile, that is levers, and then lock, and then to measure the profiles using the calipers, and then they used to add the measurements into the rough sketch drawings. So all lines profiles of the levers were annotated in a rough sketch, and then the task was to create a detailed drawing, actual drawing using the manual drawing instruments. So we avoided the computer skills over here just to make them that just to have the feel that they will do it on their own with the hands, so that they can learn to draw it and then they will learn to read it afterwards. So on regular basis they were consulted by all the faculty members regarding any inquiries, not just with their drawings but also like issues like related to how to manufacturing that component or how to fabricate the component. Even though that is just a drawing, but there will be like post processing, all those things, all those queries were addressed to all the students, and special care was taken only outside the classroom, so in improving the detailed drawings. So this is just one of the snapshot scanned view of the part drawing. You can just look into the title block where we have the drawn, it is drawn by roll number 138 Bharat and checked by others and approved by the faculty, Professor Shishal. So like that, the sense of responsibility by the team leader, that is others, used to take the care of his team student members. So likewise they were going in a very disciplined manner, that was behaving inside a team. But apart from that, technical drawing, how to improve the technical drawing, once this technical title block was ready, they moved into the drawings. So before moving to drawings, they used to get all the measurements done and then started the drawings. You can just look into the drawing. I'll move to the next slide. The kind of dimensioning annotations, like incremental unilateral system of dimensions. So you can have a look on the right side over here, 14.35 height, 6.4, 8.5, 10.6. So the kind of representation, and all this is not just printed. It is a hand drawn. It is a manual instruments drawings. And section A, you can see, look into that section A. One critical observation over here is in these drawings, even the sectional drawings, the scale is retained same. That is as per the information it is given as 2:1. So wearing the scale is also one of the skill the student has to learn. So in this component they didn't change the scale, but in the next component they have changed the scale. You can look into the section A, which is scale 2:1, section BB, which is scale 2:1. But the other drawings, they carry the scale which is mentioned in the title block. So wherever it is possible, they try to change as per the standards. So what students were doing over here is follow the key lock activity, they follow the standards, and they try to communicate thoroughly with the drawings only. The purpose of putting the bill of materials with only one row is just to have that indication where they can place the bill of materials. But other than that, since it's on an assembly drawing, but still they learn how to get that in a technical drawings. So the final observations made from this activity was where section views were included. That was I was just explaining in the last few minutes. Detailed drawings was finished. They have to submit the detailed drawings to the team leader for the approval. Then team leader used to get all those drawings of all the team members, and then focus on the flawless, means he used to correct it, and then he used to give it back to the students to correct them, and then he used to get back to the team leader, and then back to the faculty for the assessment. So this was like a continuous procedure. So once it was finally submitted to the faculty, this was the details of the evaluation. So as per our plan, we have the 80% of continuous internal evaluation, and semester examination is for 20% for this course. So this activity will be only in the CI, that is continuous internal evaluation of 80%, added the block of classwork plus assignment, 15 marks was there. So this key lock activity assessment was done for 10 marks, 5 for key and 5 for lock. So the details is measurement accuracy is 1 mark. So they used to do the measurements in front of me only, and then drawing they used to do it on their own after the explanations. So drawing the author views with annotations and section view was carrying 3 plus 1, 4 marks. So 5 for key, 5 for lock. And the last is just a sample of 4 to 5 students of how they got that continuous information, and especially that key and lock activity for last classwork. You can just look into that column of assignment 10 and key lock 5. You might be amused with the marks and also attendance because that is what my conclusion will be, just to remind you. So the targeted 3 indicators were that to demonstrate the ability to do the measurements, to generate a detailed drawing, ability to create computer models and technical drawings. So we are not worried about the computer models, but we were focusing a lot on the technical drawings, how to improve the technical drawings. So we fulfilled all the 3 indicators, and in addition to these 3 indicators, under 4 were taken care of, that is facilitating active learning and enhancing and correlating different learning styles, that is visual and active learning, and the interrelation between those 2 kind of learnings. So means what they did the measurements, they had to transfer to the drawings as per the standard. So that is kind of 2 different learning styles. Next is ability to do work in a team, to build a learning community within themselves and to work in a team. So that was learned by the students using this activity, and to build the skills. Of course, in enhancing the skills, this has been a very good activity. So this was just a snapshot of 4 candidates, 4 students for the feedback of this activity. We'll just go into one of the feedback, saying that the key and lock activity helped to gain knowledge about reverse engineering. Student at the entry level of mechanical in the 3rd semester, they might not be clear about reverse engineering, but they start to look into what is reverse engineering by this kind of activity. And we in the machine drawing laboratory, we never taught them about reverse engineering, but they try to link our activity with the reverse engineering. So that counts where that is very important thing where where it will help the student to interlink between the other subjects. So that is a part of the mainstream activity. Apart from that, the two new practices, the small practices which we adopted in this course was before after activity. So it is not just, it is off the line of key and block activity. It is before after activity, where after the course completion, the best way to make a student realize his learned skill is to know the two levels, that is the lowest and the highest level. So to show them the lowest level, that is at the first day of the course, we have to assess them in the first day only, and then at the last day, what he has learned in the last 3 to 4 months, we have to assess it. So this was achieved through a simple, that is activity, that is before to after activity. Here the candidate was asked to sketch few standard geometrical shapes on first day of the course delivery itself on one half side of the drawing sheet. And then after this machine drawing course completion, the same students were given back those sheets and asked them to sketch the same standard shapes on the second half of the drawing sheet. And there was clear-cut difference in the skill level of drawings. You can just look into the two samples. So there are four standard geometrical shapes: triangle, circle, square, and rectangle. So before is, you can just have a look. They can draw the circle or a triangle or a square, whatever polygon it is, with the help of the instruments or a pen, because they were not knowing about those things, because it was not a standard to them at that point of time. So through this course of delivery, he learned those standards, he learned those skills, and it is reflecting in the after side of the column. The same meaning, that is the same polygon is represented in the other way. That other way is nothing but the standard way. You can just look into the zoomed three images. The circle diameter 50. The circle is having two horizontal vertical axis lines, and after that the symbol of diameter, which indicates that it is a circle of diameter 50. But in the earlier case, you can look into the same candidate sketch. He has just drawn a circle. When asked to sketch a circle, he used to say a circle, but no dimensioning. So there he had that sense of responsibility that I have to convey the drawings without the help of any other language. That is what the language, the drawing language, is a mother language of the engineer. You can just look at the next square 25 also. Here is avoided the number of dimensions of the other three lines by getting that SQ or else square of 25. So like that, the line work of this sketches and all these things are manual drawn, they're not computer generated. The after part is not a computer one, it is a manual drawing only. So this kind of things, when they do it their hand, they learn it, and then they're able to they're capable to read the drawings also. And the last unique practice was the offline and online quiz. I think you might be familiar with the Moodle quiz nowadays. So student skill levels are examined through the one of the activity, that is a quiz, popular kind of assessment and very time saving also. So both offline and online quiz were conducted for this course for the set of students. So the first quiz was having 10 questions. For one batch we had 10 questions, and it was a offline test. So like the test was like fill up the blanks or answer me to the question. So we assessed the performance of the students of that set of batch. Next set of different student batch, we give the same 10 set of questions in a Moodle mode, where student has to answer with the 4 options only, A, B, C, D. And the twist what I had in this Moodle kind of assessment was, I had the answers of all the 10 questions as none of the above, purposefully. I want to check whether they are actually involving in the assessment or not, because normal students like to take A, B, C, D, anyone, A, B, C, D, but they don't look into the what is A, what is B, why it is not C, why it is not D, in that way. So the involvement question was there. So when we execute this mode quiz, we came up with this drastic results where we had this details of the performance. Offline descriptive mode gave us the average of the students. Average student scored 6.68 out of 10 marks. But in the same questions were asked in a different manner with ABCD option mode. The performance was low. It was 2.18. That indicates that the involvement in the objective mode of questioning was less when it is objective mode, or else when it is not descriptive mode. So the involvement has to be enhanced. I think the issue might be there, but I'm not also with a conclusion with this kind of results. But I'm still searching how to assess the learned skills of the students, whether in the descriptive or objective, or I don't know, in the next few days any other different tool comes for the assessment. So with this kind of three observations: key and work activity, Moodle quiz, offline online assessment mode, and then before after activity, we concluded that the involvement of the both students and faculty in this teaching learning processes was better only due to the inclusion of out of classroom activity. So take any of the technical course, have one or at least one of the activities out of classroom activity. And the second observation was this enhanced the creativity, the skill level, also the imagination of the student, more lasting impact than the classroom lecture. Normal classroom lecture, they learn most of the things, but more than that, student used to gain those skills with this out of classroom activity. And the last one is actually, this might raise your eyebrows also. The activity helped the student to overcome behavioral problems, that is working in a team, getting themselves engaged and motivated to the course. So this was one kind of address. That's why we are going to make them in a team, to work them in a team. And also this resulted in the attendance improvement. So which most of the course instructors, they might have the issues of attendance. But when I say it's attendance, it is not inside the classroom. It is in the campus, especially in the campus only. But they're spending the time inside the campus for this activity, for this course. So they might be learning some things, but it is aligned to the course. Whether it can be inside the classroom or outside the classroom, that does not matter. The mattering is what is the skill he has developed in the last 3 to 4 months. So with this short work, a small work, I would like just to conclude my talk. So any suggestions or any questions, we are free to take it. Mm-hmm. Sridhar?
Yes, sir. Were students able to perform better in this
Yeah.
course compared to previous year students' performance?
This was a pilot batch actually. This assessment was for 2014 batch. So this kind of activity is just recently concluded. So we are to compare the two batches, but the presented statistics were of the last years, and we can easily conclude that in the continuous internal evaluation only they have showed the improvement. That means there will be improvement in the batch to batch. We hope so.
How does it improve classroom attendance?
How does it is one of the the same question was asked to me in the internal department level also. How did it improve it? Student were just sitting in a classroom of 80 strength, and some of they were thinking. They actually think in these days where what to do after 4 o'clock, after 5 o'clock. So because up to 5 o'clock the timetable was scheduled for this course up to 3 to 4, 4 to 5. But I had this activity after 5 o'clock, especially after 5 o'clock, because the students will be engaged in any of one of the other courses of the technical course of third semester. So I purposely made them to meet anytime in the campus in official hours, if not after 5 o'clock. So they were in front of me at that time or else any time on that day. So that means whether he comes to the classroom or not, he is learning something in front of me outside the classroom. So there the attendance counts, whether it's inside the classroom or outside the classroom.
My question is, batch with this kind of practice and previous batch with traditional approach, is there any difference in the knowledge level or
Yes,
understanding level of the course?
there is a difference in involvement level. There, we have observed only this thing at present. Knowledge they do have it, but they lack the involvement level in expressing those learned skills. They don't have much activity apart from the normal examination kind of assessment, where they can showcase their skills, where we can assess it, not just in a kind of project or things, but in the course only. So I think students were in the advantage side.
It is interesting that the students thought of reverse engineering. Did any student want to explore different
Yeah.
methods of reverse engineering?
And we, that's what I told sir, we never discussed about reverse engineering in the classroom. This feedback was taken after the course, since this activity was after the course only, almost at the end of the course. And the student have learned the reverse engineering some of the other course, and they try to link over here. And I can assure that they have linked this reverse engineering to one of their other courses, or else this course on how to get this drawing forward to the next department, so that they can manufacture the key or lock, or how well it is good enough, the technical drawing is good enough to give it to the shop floor so that it can fabricate that key. So reverse engineering is one thing, but at least in one way if he learns, the second way if he learns in the other course, then I think our job is done. As a teacher, our job is done.
One of the participants says, a very good initiative from your side, congrats.
So sorry sir,
Yeah, one
I
of
didn't.
the participant is telling a very good initiative from your sides and congrats.
This one I guess. Okay, participants only, not the students. Okay, okay, thank you sir, thank you.
Yes. Could you share more detail
Thank
about
you.
before and after assessments?
Before and after, okay. Before after, okay, I will just like to go in depth with this activity. In the first day, when I introduced myself to the students, in the first minute only, after their introduction of their name, where they came from, I also introduced myself. Immediately they were given that I will be handling this course for for the next 6 months, and they were handed a drawing sheet. So on one side of the drawing sheet, I asked them to write them a before heading, and I asked them to sketch a triangle of 25 cross 25 mm, right angle triangle, and I asked them to sketch a circle of 50 diameter, a square of 25 mm, and the rectangle of 40 25, 40 cross 25. They sketched it. I had given them 5 to 10 minutes of time. I was not restricting them to sketch it in this way or that way. Whatever they had learned in their school level or else college level, +1, +2, they executed those things in that before category, before column. And I took over the drawing sheets of all the candidates. I retained it until I completed my last class or last session of my course. And then before ending my course, I just handed the same sheets to the same candidates and asked them to sketch the same polygons, and then they sketched with the help of the instruments which are standard: scale, protractor, pencil, pencil of those grades only, and the kind of dimensioning they have learned in the last 3 months. So they tried to compare the two drawings of the same candidate. So there they can look into that before and after. It is like a normal commercial which we look into in a television, where we can say face cream before 6 months, 6 weeks, and after 6 weeks. Like that kind of clarity they were having in their learned skills. So that kind of activity I just had it over here, so that they they can analyze what I have learned. In the next 40 years, if anyone asked him to sketch any of the polygons, then he will use those standards only wherever he is there.
Hello.
Uh,
Yes. Were there only drawings? Any effort in the direction on getting a comprehensive idea about student learning?
I didn't get you, sir. Student learning?
Any efforts in the direction on getting a comprehensive idea about student learning?
I didn't get your question properly, sir. Sorry.
Okay, so I will ask them to clarify. He's saying in
Okay, sir.
continuation with the previous question
Okay.
about the assessment.
Assessment. Okay. This one. This one. Assessment.
I hope he can clarify, sir.
Okay. I would like to just have the question again. It was not clear.
So he says, were there only drawings? Any effort in the direction on getting a
Mhm.
comprehensive idea about student learning?
Yeah. It was only drawings, and the student learning was to improving the drawings only as per the standards. It was including, I think, sectional views, how to get a sectional view, how to vary the scale, how to get the annotations proper. And here we didn't use the tolerance for this kind of thing because they were in the initial learning of the drawings. So we didn't want to burden them in reading the drawings with the tolerances.
Thank you very much, sir. Those are all the questions. Thank you for the time.
Thank you, sir. Thank you. Thank you.
Bye.
Okay, thanks.